Suppose you're given a second order differential equation like this, and you are told to find solutions in this specific form. What do? Well, you just plug them in. So you take y as one of the solutions and find the two derivatives and plug them in and see what you get. Okay. So the first derivative, 1 differentiates to 0, 3 comes down, 6 comes down, and that's how you get the first derivative, right? And if you differentiate again, 2 comes down, 2 times 3 is 6, 5 comes down, 5 times 6 is 30, so you get this result. And now we're ready to plug them in. This y double prime can be replaced by 6a3x plus 38.6x to the fourth, whereas the y here can be replaced by, this y can be replaced by 1 plus a3x cubed plus a6x6. Okay. And therefore, what we get is this equation here, where this really is y double prime, this is really y. And you can expand this by multiplying the 2x to each of these terms. So that 2x times 1 gives you 2x times a3x cubed. X times x cubed gives you x to the fourth. So you get 2a3x to the fourth. 2x times a6x6. X times x6 gives you x to the seventh. And so on and so on. And then when you look at this closely, you see that this is x to the power of 1, and this is also x to the power of 1. This is x to the fourth, this is x to the fourth. So you see that these two terms, the 6a3x and 2x, they can be combined as the x to the first power term. 38.6x to the fourth, 2a3x to the fourth, they can be combined as x to the fourth power term, and so on and so on. So if you do that, we get this, and you get this. We also have x to the seventh term, but if you also want to work with that, you need to identify what comes afterwards, because, see, 0, 3, 6, the next term here is a9x to the ninth, and if you differentiate twice, that's x to the seventh term. So there is an x to the seventh term with some multiple of a9, and that can be combined here, but the question only asks for the value of a3 and a6, so we can just stop here, okay? All right, but anyways, you have this power series equal to 0, and there's an important theorem. It's called the identity theorem, which says that if a power series is equal to 0 for all values of x, then each individual coefficients should be 0. So we know that this has to be 0 and this has to be 0, and you just solve it and you get the values. Now, one thing that I want to say is that the first one, it's easily just a3 goes to negative 1/3 just by solving. But to solve the next one here, this is the equation I want to solve. For that, since a3 is obtained as negative 1/3, negative 1/3 has to be put in there. And the resulting equation is 30a6 minus 2/3 equal to 0. And when you solve this, you get a6 as 1/45. And you can do the same thing for the other one. So to get the b4 and b7, now start with y equals to this thing. You find the first and the second derivative, plug it into this differential equation, and just do the rest.